Hi everyone. So today's lesson is on chapter 5.1, reciprocal functions. We should all know what a reciprocal function looks like. I have the graph over here to show you. Based on the definitions of the word reciprocal, what we do actually is we just take the functions, okay, and to make it 1 over. So if you look at the features of the reciprocal functions, we all know that it has a domain of x does not equal to 0, and because of that, the range y cannot be equal to 0 as well. And because of the domain and range of the reciprocal functions, so we know that there are some asymptotes on it, and because x does not equal to 0, and that's how it generates a vertical asymptotes at x equal to 0, and because the range cannot be equal to 0, so therefore we have a horizontal asymptotes at y equal to 0. Okay, so those are the basic characteristic of the reciprocal functions. But if you look at the definitions of the reciprocal, what it really means is that any given functions, when you take the 1 divided by that function, and that is how you get the reciprocal. So if you are taking the reciprocal functions 1 over x and reciprocal that again, and you will go back to have a functions of y equal to x. Okay, so that means the reciprocal of the 1 over x will become the x, or the reciprocal of the x will become the 1 over x, vice and versa. Okay, so if I'm putting the two graphs on the same grid, as you can see, so the blue one is the reciprocal functions y equal to 1 over x, but the red one is the reciprocal of the reciprocal, which is the y equal to x. And I want you guys to look at some of the key points there, so you can see how some of the key points will get for the same x, you will get into a different y coordinates. For example, there's a point at the y equal to x for 2, 2. So this is the point on the graph. Okay, for that same point, if you look at the reciprocal of it, for the x equal to 2, then the y coordinate will becomes a 1 over 2. So as you can see here, for the x equal to 2, the reciprocal functions y equal to 1 over x will have a 2, 1/2. Okay, so this point here is the reciprocal of that point from the two different graphs, or vice versa. Okay, same for the -2. Same for the -2. Okay, so for the y equal to x functions, when you have a point at -2 and -2, that point, the reciprocal of that point will be a -2 and -1/2, which is right here. Okay, because what we did actually is for the same x, -2, -2, just the y coordinates get to reverse by dividing, like 1 divided by the y coordinates. Okay, so 1 divided by -2 will give you a -1 over 2. Or if you divide 1 by a -1/2, you will get a -2. Okay, so the only points that will not change the y coordinates is when the y coordinate is either 1 or -1. Because think about it, if you divide 1 by a 1, you still get the same result. Or if you divide 1 by a -1, you still get the same -1. So those are the only 2 points really that are the same, and that is, you can see from the graph that they are intercept each other at that point when the y coordinate is equal to 1 or -1. Okay, so basically this is what the reciprocal function is all about. Okay, later on when we're trying to graph the reciprocal functions of any given functions, this is the main rule that we always have to keep in mind, is that any key points, just take the y coordinates and take the 1 divided by the any given y coordinates, and you will get the reciprocal points of it, okay, for the same x. Now, let's take a look at the handout, the first handout of 5.1, okay. On this handout, we get to have a lot of practice on the concept of a reciprocal. So for example number 1, we want you to find the reciprocal of each of the following. So the concept is, again, how do we find the reciprocal? All you have to do is take 1 and divide it by the given questions. So for example, A, you have a fraction 2/3. When you do the reciprocal, meaning you take 1 divided by the 2/3, you get flipped. So your answer will be a 3/2, because after you take 1 divided by the 2/3, you get 3/2. Okay? Next one, same thing. The reciprocal of a -5/6, when you take the 1 divided by that fraction, it flips. But the sign doesn't change. You still get a negative, but now it's a -6/5. Okay? When you get a 1 divided by 1 will still give you 1. Same as the -1. We did that as well. Okay, now when it comes to questions E, if the question start with a 0, okay, so the reciprocal of a 0 will be a 1 divided by 0, which give you undefined. So that's why you will get an undefined over there. Okay, and if the question is a function like y equal to x, that means now you will have a y equal to 1/x, because everything here for the y coordinates, you take the 1 divided by the x, okay? And if the function is y equal to 3x minus 2, so all you do, you take 1 divided by 3x minus 2. So now the functions will become y equal to 1/3x minus 2, okay? Same thing with the quadratic. If this is a quadratic functions, all you have to do is take 1 divided by the whole thing, okay? The whole thing. And if you have an expression like y equal to f of x, then this will become y equal to 1/f of x, okay? So it's pretty straightforward. This is what we do when we ask to do the reciprocal. Basically, you just flip the y coordinates, right? Why are we flipping it? Because we always do the 1 divided by, okay? And some of the characteristic of the reciprocal functions, I already outlined it on the bright space, like where it's on this particular unit. I already list all of them here, but some of them on your worksheets you get to see. They are pretty much the same rule, okay? So when it comes to the graphs of the reciprocal functions, you just make sure that you have all of these points check off, okay? So some of them, such as if we look at example number 2, okay, you have a linear functions given. So the black line is the linear functions that is given. I don't have the equations of it. If I have equations like the one at the top here, I know that I can just do it as a 1/, and then you can get some of the key points from the table values, but that is very time consuming, right? So what we usually do when we want to graph the reciprocal of any linear, so first of all, we graph the linear, we graph the line, and then from the line, we are going to do or to check off some of those key features that we need to do for its reciprocal, such as if you start with the first point, whenever there's a 0 in the function, there's a vertical asymptote in 1/f of x. Okay, which is true. So this linear here has a 0 at x equal to 6. If this point here will be a 0, comma 6. If I need to do the, sorry, this point here is a 6 comma 0, not 0 comma 6, my bad. Okay, so this will be, let me just do it over here. If I want to continue with the points, if I have a point of a 6 comma 0, then this point, the reciprocal of this point, it will be a 6, 1 over 0. Okay? And we all know that a 1 over 0 is the undefined. So therefore, any 0 of the original function, like in this case, where it has a 0 at 6 comma 0, then this point will becomes undefined. So on its reciprocal, it generates the vertical asymptotes right there. So this is what we are referring to, where there's a 0 on the original function f of x, there is a vertical asymptote of 1 over f of x. So this is where the vertical asymptote is happening. Okay? So usually for the linear, there's only one vertical asymptote because the line only crosses the x-axis once. Okay? So think about that. If this is not a linear, if this is a quadratic, then it's quite possible when the quadratic crosses 0, cross the x-axis for more than one point, then you will have more than one vertical asymptote in that case, okay? You will see that later on in our example. So let's go to point 2. The points that has a y-coordinates of 1 and negative 1 will be the same for both f of x and 1 over f of x, which is the reciprocal of the original functions. So then we're going back to the graph to check, to see where the linear has a point that has a y-coordinates of 1. So this really is the point where the y is equal to 1. And also over here is where the y is equal to negative 1. Okay? So that is the reason why I plot a point there, because this, I know that this is where the two graphs is going to intercept each other. Okay? So that is a point 2. Now, the interval where the function is positive, meaning it's above the 0. So for the original function here, is anything that when x is greater than 6 is when the function is above the x-axis. Okay, so you make sure that the reciprocal also is above the x-axis. Okay, same thing here. The interval of the original function is negative, so which is, if you go back to the original functions, the linear, anything that for x is less than 6 is where the original function is below the x-axis. So its reciprocal is also need to be below the x-axis. Okay, so that's why you see my reciprocal crossing the point of intersections of the two, and it just go toward the 0, but it just never go above. Okay, so this is point number 3. And number 4 is the interval where the function is increasing, the reciprocal is decreasing. So the interval of increase and decrease basically is the opposite of each other. So let's say if we are looking into, the original function has interval of increase throughout. So that means it's reciprocal. They all have to have the interval of decrease throughout and no interval of increase. So if you look at my final graph of the reciprocal, as you can see from left to right, my reciprocal function is decreasing. Okay, so that is about point number 4. And finally, number 5 is the reciprocal functions of any function as long as a linear and quadratic. It always has the horizontal asymptotes at y equal to 0. So that's how I label this on here as well. So for this particular example, A, 2A, I have one vertical asymptote because there's only one 0 from the original. I also has a horizontal asymptotes at y equal to 0 because this is a linear. So any linear or quadratic, you always get the horizontal asymptote y equal to 0. So when I connect everything, everything I can do basically is I make sure that they all intercept at a point where the y is equal to 1 or negative 1. And make sure that they all have the same positive or negative interval. And also I need to make sure that because the original linear function has interval of increase only, so the reciprocal only will have the interval of decrease. Okay, so after you kind of generate or graph your reciprocal, I want you to go back and make sure that you do all this checking. Okay, so let's look at the next example. Is another linear again. Okay, but this is a line that with a negative slope. Okay, it doesn't really matter, but if we go by the those checklists, I know that the first thing that I will make notes of is the vertical asymptote, or where the linear is crossing the x-axis. So right now the line is crossing the x-axis at 3, 0. So 3, 0. When we try to do the flip by dividing 1 over the 0, you know that this is the point where the reciprocal will have the vertical asymptotes on it. Okay, so vertical asymptote x equal to 3, because this is where the 0 is happening for the linear. Okay, and the next thing that I would do is I will find where the linear has a y coordinate that's equal to 1 right here, or the negative 1 right there. Okay, I plot it because I know that this is exactly where the two graphs is going to intercept each other. And then I want to make sure that anything less than 3 for the original is above the x-axis, so my reciprocal will also follow that. And for the x that's greater than 3, my linear is below the x-axis, so which is in a negative interval. So I also make sure that my reciprocal also stay below the x-axis. And because this linear function has a negative slope, meaning that is getting an interval of decrease throughout. So I want to make sure that my reciprocal, it only has interval of increase. Okay? And make sure that the tails of your reciprocal function always go approaching to the asymptotes, whether it's the vertical asymptotes or the horizontal asymptote. So again, because this is a linear, so I also will have a horizontal asymptote at y equal to 0. Okay?